All right, here we go. Unit 3, Day 2, factoring when a is not equal to 1. What I mean by that is today we're going to work up to the point, we're going to build our muscles until we can factor expressions where instead of an x squared, where there is an implied or an understood 1, that's what an a term of 1 means, we're going to be dealing with 2x squared, 3x squared, 5, 6x squared. So by the end of today, you're going to be able to factor expressions that have those other leading coefficients. Here's a reminder of the key points from last class. Number one, the zeros of a polynomial, it's a vocab term, the zeros of the polynomial are the x values that if you plugged them into the original function would give you 0. So they give us points on our graph of x comma 0. That's why they're interesting, is that they are going to tell us our x-intercepts. And so if we had a function like f of x is x squared plus x minus 12, we could play around for a while. We could say like, okay, let's try 4. 4 squared is 16, plus 4 is, so you'd have like here, you'd have 16 plus 4 minus 12. Close, that would be 8. Right, so you could play around for a while. You'd eventually get to, okay, if x was 3, you'd have 3 squared to make 9, plus 3 minus 12, that would be 0. Okay, so you could try and just find these by trial and error. But an easier way to do that is with factoring. It's kind of why we use factoring, one of the main reasons. And so what we do is we take our expression, f of x equals x squared plus x minus 12, and we set it equal to 0. We say, I want to know, when does this expression equal 0? And so we take x squared plus x minus 12, and yesterday all we were dealing with was when this x term was a single x squared. This x term was a single x squared. That is what I mean by an a coefficient of 1. And the reason that that makes things easier is that we can just say, okay, I want to know, how is this going to be broken apart, this trinomial? And I already know that my first two terms have to be x. The first two terms have to be x so that when you multiply them together, you get x squared. Now, we learned that honestly the fastest way to do this is to just think, okay, what can multiply to make 12? 1 and 12, 2 and 6, or 3 and 4. Now in this case, this is a negative 12. So what that means is one of these is going to have to be positive and one of them is going to have to be negative. In the middle, they make a positive x. So you do a bunch of these and you realize, okay, if one of these is positive and one of these is negative, we must be dealing with 3 and 4. And since the multiplication, when we do this back, gives us a positive x in the middle, it must be a minus 3. Let's see why that has to be true. If we make this x plus 4 and x minus 3, if we finish this out, we'll have x times negative 3 to make negative 3x, 4 times x to make plus 4x, and 4 times negative 3 to make minus 12. So see, this is why your numbers have to multiply to make negative 12 and add, just showing you that this works. This is just like the check. And they add to make 1, that 1x in the middle. Now, why this is helpful? If you look at this factored expression and you think back to the original question, finding the zeros or x-intercepts, we have something that we call the zero product property, which means that if either of these two parentheses is 0, either one, if either one of these is 0, the whole thing is 0. And so remember, we found by guess and check, we already knew about 3. And that checks out because if you plug a 3 into the x minus 3 term, you get 0. The other one is the number that would make x plus 4 0 if we plugged in for x. So it's the opposite. It's negative 4. And so, we also know that the y-intercept here is negative 12 because that's what would happen if you plug in 0. And so, we can make a decent-ish graph by just saying, all right, our function has x-intercepts at negative 4 and 3. so it's symmetric about that line. You could do like a decent approximation of what this looks like just by investigating those key points. Okay, so that's the whole why. Today we're going to focus on specifically this factoring technique because we're going to do ones where it's not just x squared. So let's see what this looks like, right? To get our brain in the right space, this is just a little, you're going to see this on the Delta Math. It's just like doing this backwards. So when you go to the Delta Math today, it's going to be like, okay, how many of these can you do really quickly? And it's just to get your brain thinking about those middle terms. Notice the end term is easy. 7 times negative 3. These are all negative 21. So we can't eliminate any answers. The first term is easy. 2x times 2x, 4x squared. So what these are testing your ability to do is to quickly say, what are my two middle terms going to be? I'm going to have 2x times negative 3 to make negative 6x. And we're going to have 7 times 2x to make plus 14x. So 6 and 14 combine to make positive 8x in the middle. So that's just to get your brain in the right space because it's going to feel like a puzzle today. And I want you to do that one first just to get you thinking about middle terms. And so here we go. Now we just need to do it backwards. Factoring a trinomial, ax squared plus bx plus c, when the leading coefficient, the a term, is not 1. So the factors of the leading coefficient, well, 3x squared, the only thing that can be is 1 times 3. So this is like the base level. 3 is a prime number. Its only factors are 1 and 3. Then we'd think about 35. 35, our c term, could be 1 times 35, or it could be 7 times 5. Those are the only factors of 35. And so we know to make 3x squared, there's only one way this is going to set up. This is going to set up with a 1x and a 3x, right? Because if you multiply these things out, 1x times 3x is 3x squared. Now, there are 4 instead of 2 options, and I want us to see this really quickly. We could have 1 and 35. We could have 35 and 1. The order matters because only one of these things is going to get multiplied by the 3x. The other one just gets multiplied by 1x. We could have, I'm going to leave that 3x squared there. We could have a 7 here and a 5 here, or we could have a 5 here and a 7 there. So you have to run through and see what are all of these possibilities going to work out to be. Okay? So let's take a look at this. If we need the middle term to be 26, and trust me, you're just going to get faster and faster and faster at this. You can run through, worst case scenario, you try all 4. So let's say the first thing we did was we put a 5 here and a 7 here, both positive. Well, we'd have 1x times 7 plus 7x, 5 times 3x plus 15x, 5 times 7 plus 35. Well, 7 and 15 in the middle, those would get me 22x. I wanted 26. I wanted a 26x in the middle, so that one is not correct. So we try again. We do over here 1x, let's switch them around. 1x plus 7 times 3x plus 5. 1x times 3x is 3x squared. 1x times 5 is plus 15x. 7 times 3x, 1x times 5 is plus 5x. 7 times 3x is plus 21x, and 7 times 5 is plus 35. 3x squared plus 26x plus 35. There it is. So our correct factorization is 1x squared times, 1x plus 7 times 3x plus 5. So we now know that the correct factorization f of x equals 1x plus 7 times 3x plus 5. Now we'll do a real quick preview. We'll hit this harder on a future day. If I wanted to find the zeros, I want to know what are the x values that would make either of these parentheses 0. The first one is not that bad to see. The first one is just x equals -7. And we can see right there, x equals -7 is one of our zeros. The other one, though, you can see it's between -2 and -1. It's a decimal. The reason it's a decimal is because you want to know, when does 3x plus 5 equal 0? You subtract 5 from both sides, you get 3x is equal to -5, and you divide by 3, you get x is -5/3. So that right there is -5/3, comma 0, and this right here is -7, comma 0. Point of the story is it's a lot of trial and error. Trust me, you will get faster at this. You just need to run through all of the factors to find the correct one. Let's do one last one. I want you to see one. This is as hard as it gets. They won't all be this hard. Let's factor 6x squared plus 17x plus 10 to find these zeros. The reason this is hard is that 6 could be either 1 times 6 or 2 times 3. So what that means is you have to think about, maybe it's 1x times 6x, or it's 2x times 3x. And so there are more possibilities that you have to consider. 10 is either 1 times 10 or 2 times 5. So you have to go through and you have to try 1, 10. You have to try 10, 1. You have to try 2, 5. You have to try 5, 2. So it's going to be building a lot of mental math muscles. And so let's see. If I put a 10 here and a 1 there, I'd have 60x and 1x in the middle. Nope, I'm trying to make 17. Let's switch them around. I put a 1 here and a 10 there. I'll have 6x and 10x. Ooh, 16, close, but not quite. So 1 and 10 is out for that first one. Let's try 2 and 5. 2 and 5. 2 times 6 is 12. 5 times 1 is 5. So we have 12 and 5 to make 17. That ends up being correct. So we finish this off. F of x is equal to 1x plus 2 times 6x plus 5. Let's check that this is the correct factorization of 6x squared plus 17x plus 10. Let's check that this is the correct factorization. You'd have 1x squared plus 5x plus 12x plus 10. Yes, 6x squared. 6x squared plus 17x plus 10. That's it. That's our correct factorization. Using the zero product property, 1x plus 2, well, that would be equal to 0 when x equals -2. So that checks out. 6x plus 5 would be equal to 0, well, when 6x equals -5, or when x equals -5/6. And so that right there is going to be -5/6, comma 0. This right here is going to be -2, comma 0. That is the zero product property. So we got a little lucky there, but worst case scenario, you would have had to try 4 things. It's just a matter of trying, getting better trial and error, improving your mental math. It's really good for your brain. The Delta Math will help you get there as well.